Hey, this is Neil from Gradesavers, and today we're doing question number 41 from section 7.2. Let's begin. The question reads, what is the integral of x cubed times e to the power of negative x squared over 2 dx? And they would like for us to do this question by first making an appropriate u substitution and then using integration by parts. So for us to use u substitution, let's let u equal to minus x squared over 2, and this means that dx must be equal to du divided by the derivative of minus x squared over 2, which is simply minus 1/2 to x. And we see here that this 2 here and this 2 here cancel out, so we're simply left with du over negative x. So let's begin our substitution. Our integral will now become the integral of x cubed cannot be replaced by u or dx, times e to the power of u, because minus x squared over 2 is replaced by u, and dx is replaced by du over negative x. And now let's simplify. This x cubed divided by this x here becomes simply minus x squared e to the u du. And now we're at a bit of an impasse. Here there are two different variables, but we need to get rid of the x variable. So we need to look back to our original u and see if there's an appropriate substitution we can make. Well, if we rewrite this and solve for x, it turns out that x squared is equal to negative 2u. So that's what we can substitute here. That's what we did right here. So now it becomes negative multiplied by negative 2u e to the u du. And when we simplify this, the negative times negative becomes positive, so we are left with 2u times e to the power of u du. And now this integral here is something where we can use integration by parts. And we need to select a u and a dv. So for simplicity's sake, I have called it u1 and v1 since we used u already here once. So u1 is equal to 2u, which means everything else that remains, so once we get a 2u, everything else that remains is our dv, which will be e to the u du. In order to find du1, we simply take the derivative of 2u, so that's 2, and we slap on a du. In order to find v1, we integrate e to the u du, or find the antiderivative of e to the u, and that is eu. And now we can put this together using the formula. So this becomes u1 times v1 minus the integral of v1 du1. And we see here that there is really no simplification that can be done for the first term. However, to make the question easier to read, we can bring the constant to the front. So we could see this is the integral of 2 times e to the u du, and it's a very easy antiderivative or integral for us to find because it will simply be the constant times e to the u. So this becomes 2u e to the u minus 2 times e to the u plus our constant c. Since we've gotten rid of all our integral signs, we should slap on our constant c now. Now, in order to get to our final answer, since we started with a substitution for u, we said let u equal to minus x squared over 2, we need to back substitute. So we go and start putting wherever we see a u, negative x squared over 2. So this becomes 2 times negative x squared over 2 e to the power of negative x squared over 2 minus 2 times e to the negative x squared over 2 plus our constant c. And we can begin simplifying. So this 2 and this 2 cancel out. So we get this line here. That's really the only simplification in this line. And in the final line, all we do is factor out the negative e to the power of negative x squared. So all we're left with in our bracket is x squared plus 2. And don't forget your constant c, and that's it. Hey, thanks for watching. Grab the PDF from below, and remember the best way to study is to join the Gradesavers review sessions.